Alright, so I'm going to give you a video lesson today. This is section 12.2 out of our text, and the topic is surface area of prisms and cylinders. I'm going to apologize ahead of time today. My whiteboard was not working very well when I recorded this, so I hope that you'll be able to read what I'm trying to tell you, and I'll talk through a lot of it too. So some terms here to start. So obviously our first term is going to be surface area. We haven't talked about that before in this class. So what exactly is surface area? Quite simply, surface area is the sum. So remember that. Alright, sum. The sum of all of the areas of all of the faces of any three-dimensional object. So quite simply, it's finding the area of every single face of that object and then adding all of those areas together into one total. Alright, and that would be considered the surface area. I like to think about it as how much paint would I need to paint the outside of this object. Alright, so if I give you just kind of an idea here as I break this thing down. So for this rectangular prism, I've got two faces that look like the front and the back. So I could find the area of one of those and times it by 2. I've got two faces that look like the right and the left hand sides. So I could find the area of one of those, multiply it by 2. And of course I've got two faces that look like the top and the bottom. So I could find the area of one of those and multiply it by 2. And then when I'm done with all that, I'm going to add that up, and that would be my surface area. You really don't need any more fancy of a formula than just that. Okay? Now, within surface area, there are a couple of other terms. One of them is lateral area. Remembering what lateral faces are. Remember, the lateral faces are the ones that aren't the base, right? They're the ones on the sides, if you will. So lateral area is just the sum of all of those faces, all the ones that are on the side. So in this picture right here, it would just be the 4 that aren't the front and the back. I would consider the front and the back to be my bases, and so the lateral faces would be those other sides, right? Okay, the left hand side, the top, the bottom, and the right hand side. Alright, so it's all of the faces that aren't the bases. Okay, so I'm going to talk about lateral area a little bit later when we get to the formulas. So just so you remember that it's just the area of the lateral faces. Remember, you can always stop, rewind this, go back, copy some things down if I'm going fast or if you've missed something. Okay, I'm going to switch gears a little bit here now. We're going to talk about our third term today, and it's called a net. And I know there's lots of different definitions for what a net is, but geometry speaking, a net is a two-dimensional representation of a three-dimensional object. So a 2D picture of a 3D object. And what I mean by that is, the best way to think about it is if I had an object that was made out of paper, like a three-dimensional object made out of paper, if I cut that apart and unfolded that piece of paper, that's what a net would look like. Alright, so it's an unfolded or a cut apart three-dimensional paper object. I'm not sure if that makes a whole lot of sense. I'm going to give you like a little picture here so you understand what I'm talking about. I've got a triangular prism, okay? So I have a triangular prism here. Remember, that's a triangle on each end, all right, with some rectangles in between. If I pretended that was made out of paper, okay, or cardboard or whatever, and I tried to cut it apart, all right, I would have some rectangles, and then in addition to having those rectangles, I would have a couple triangles, one on each end. Alright, I'd have the triangle on the one end, triangle on the other. This is one way that you could have a net. You can kind of see how I could fold that up, alright, and create that prism out of it. If I put some dimensions on that, alright, and I made the two sides of the triangle 10 and the base 12, and if I made the distance in between the two triangles, let's say 15, alright, this is where those dimensions would end up on my net. Just so you can kind of see a little bit of how that looks. Alright, that's kind of where the dimensions would be. I'm going to move the triangle on the bottom so it actually looks a little more correct. I've got this a little bit wrong right now. So, and your net can look differently depending on how you cut it apart and all. All right. So this right here would be an example of a triangular prism net. All right. And why would we use that? Well, the obvious reason I can use this because I could find the area of those pieces really easily, and then add all of those together, and that would give me the surface area. Right? The surface area would just be the area of those blue rectangles plus the area of the two red triangles. All right. So some people like nets because it's easier for them to see all the faces that they need to find the areas of. Okay. I'm not a huge fan of nets, but I can certainly understand why some people like them. All right, the last two terms we're going to talk about are related to each other. We're not going to talk about the one very much right now, but the first term or the next term in our list is right prism. Right prism. The definition of a right prism is a prism whose lateral faces and lateral edges, all right, the sides of it, are perpendicular to the bases. All right, a prism whose lateral faces are perpendicular to the bases. So the big key here is the word perpendicular. Perpendicular is why this thing is called right. All right, those are the two terms that kind of come together. So these are the prisms that you are used to seeing. All right, they're the ones where the two bases are directly above each other. All right, if it's sitting on a base, or it just looks like your normal looking prism. Okay, 99% of the prisms that we're going to look at in this class are going to be right prisms. Okay, so I would say they're the ones that are normal looking. Now, if there's a right prism, then there must be another kind of prism. Not called a wrong prism, as I know you probably thought I was going to say. It's called an oblique prism. O-B-L-I-Q-U-E. Oblique. And the definition of an oblique prism is just simply the opposite. It's a prism whose lateral faces and edges are not perpendicular to the bases. Alright, so it doesn't look like your typical traditional right prism. Alright, the best way for me to kind of describe it would be like if you had a shoebox and you stepped on the shoebox, or you applied a little pressure to the box and the sides started to tilt a little bit on an angle. That would be an example of an oblique prism. We're going to talk more about oblique prisms down the road in a couple sections. But for today and for the next little bit, we're only going to be working with right prisms. All right, so just kind of store this in your brain. We'll come back to that later on. So let's get to the real important stuff here, and then that is, how do you find the surface area of prisms and cylinders? All right, so your formula for the surface area of a prism, okay, surface area equals lateral area plus 2 times the area of a base. Okay, so surface area equals lateral area plus 2 times the area of the base. Now the base can be anything. The base can be a triangle, a square, an octagon, all right, a trapezoid. So I can't give you any more specifics about that. All right, it's going to be whatever the area formula is for that particular object. But the lateral area will always be rectangles. Let me just give you an example here what we're talking about. So suppose I have a right triangular prism. Okay, so it's a right triangle base. All right, and it's a prism. So let's say those dimensions are 12 by 10, and then the distance between the bases, we call that the height of the prism. All right, the height of the prism is 20. All right, so lateral area. All right, so it's the bottom, so that's 10 by 20. That's a rectangle down there. It's that left-hand side, which is 12 by 20. And then if I calculate my hypotenuse here by using Pythagorean theorem, all right, my hypotenuse is going to be about 15.4 or so. If I find that, then I've got that last rectangle, which is going to be 20 times 15.6. All right, I can take those 3 areas, all right, the bottom rectangle, the left rectangle, the top rectangle. I can find those areas and add them together. And when I add those together, that's going to give me my entire lateral area. Remember, that lateral area is all the areas around the rectangles of the prism. Alright, now I'm going to work on the area of my base. Remember, my base here in this case is a triangle. So my triangle formula is going to be 1/2 times base times height. The beauty about working with a right triangle like this is that I already have my base and my height. They're already the two sides that are perpendicular to each other. So 1/2 times 10 times 12. Remember, you can multiply those in any order you want. So half of 10 is 5, and 5 times 12 is 60. And so that's going to be one base. Now I multiply that by 2 because there's a triangle on each end. So that's 120. And now I can take those two bases and add it to my lateral area that I did just a few seconds ago. And that's going to give me my entire surface area of this right triangular prism, which is going to be 872.4. And we're going to label that units squared because it's area, and area is always in square units. So, very simple, straightforward example of a surface area problem. Remember, you don't really need formulas for all this though. If you're okay with just finding the areas of all of the faces of that thing, then go ahead and do that. I mean, that's really all I just did. I didn't do anything really fancy. I didn't do any special kind of work here with this. I just found the area of each of those triangular faces. Okay? Now you can, there is a shortcut to finding lateral area. So for those of you who like to try to find fast, efficient ways to doing things, the lateral area of any prism is going to be the perimeter of the base times the height of the prism. The perimeter of the base times the height of the prism. And what that does is it gives you all of those rectangles all at once. Instead of breaking it up into 3 rectangles like I did earlier, it would give you all of them at one time. Please remember, if you're going to use this, it's the height of the prism, not the height of the base. The height of the prism is defined as the distance between bases. So again, I'm going to show you a little picture here. All right, if I have a hexagonal prism, all right, I say the height. The height is not how tall the hexagon is. The height is how far is it from one of the hexagons to the other. The distance between bases. So if you're going to use this formula, be very careful with that and make sure you know what the height is. All right, it might be something you ask me in class to explain again or to show a little more clearly. So that leads us into how do you find the surface area of a cylinder? Well, remember, in my opinion, a cylinder is just a circular prism. So it shouldn't be too surprising to find out that the surface area formula for a cylinder is exactly the same thing as it is for a prism. It's the lateral area plus 2 times the area of the base. Now what's different about the cylinder is the cylinder is very specific. It's always circular. So I can make this formula a little bit more specific than I could for prisms, because prisms have different bases. This is always going to have a circular base. So if you watch me right now, I'm trying to break this formula down into a little bit more specific parts. Alright, so since it's always a circle, that perimeter is really circumference, which is pi times the diameter, which is really 2 times pi times r. I know we don't use that very often, but I'm going to show you why I'm using it right here. And obviously the area of the circle is pi r squared. So I'm going to do a little factoring here. I'm going to pull out a 2, a pi, and an r. And what that leaves me left with is an h in the first part, and then there's 1 r left in the second part. And so this is a really short, relatively easy to use formula to find the surface area of any cylinder. It won't work for a prism, obviously, because you don't have radii in prisms, but it is a nice way to find the area of a cylinder. Okay, you do not have to do it this way. You can break the cylinder apart and again find all of its faces, but that's a little bit harder with a cylinder because of the fact you've got that rounded side, that rounded lateral face. So here's me using the formula real quick here. Alright, I've got a diameter of 12 and I've got a height of 20. Remember, the height is the distance in between bases. Alright, and so my surface area formula is just going to be 2 times pi times the radius. The radius would be 6 in this problem, times the height of 20 plus the radius of 6. Alright, please, I messed this up. I can see this already. I'm messing this up. Remember, use the radius of 6, not the diameter of 12. Alright, use the radius of 6. And when I multiply that out, that will give me my answer. If you keep watching here in just a few moments after I give you the homework assignment, there'll be a video to help illustrate why the surface area and the lateral area for a cylinder is what it is. Alright, I'll give you a little bit more of an explanation for why lateral area of a cylinder behaves the way it does. Alright, work on some of these practice problems. Be ready to discuss these tomorrow in class if you have any questions at all about anything that you don't understand. Alright, so I wanted to show you why surface area for a cylinder has the formula the way it does. And the best way to illustrate it is with a toilet paper roll. Alright, so remember I told you while you're at home and you're bored and you're going to the bathroom, this is a good way to fill your time. Okay, so I've got my toilet paper roll here like a cylinder. Alright, and just to give you an idea here, the dimensions on this, I've got 4 inches for the height. Remember, the height is the distance between the two bases, and then it's got a diameter that's about, I don't know, 1.5 inches or so, maybe a little under 2 inches. That's not super important, but I want you to think about the 4 inches here. So I'm going to show you what happens. All right, if I take the toilet paper roll and I cut up along the side of it, all right, I want you to watch here, okay? As I take that, all right, and as I unroll that, the sides of my roll, all right, the lateral face of my cylinder, all right, as I unroll it, it becomes a rectangle. So it's a lot like a prism that way. All right. Now, what are the dimensions of that rectangle? The easy one to see is the height. All right. As I unroll that rectangle still has a height or a length, if you will, of 4. But what about this piece right here? What about this length here across the top? Again, watch. As I take that and I unroll that, what used to be the circumference of the circle is now the width of the rectangle. I could actually take that diameter that was almost 2 and multiply it by pi, and that would be my width of my rectangle. So remember, in the formula for surface area, the lateral area is the circumference of the base times the height of the prism, and the reason for that is because those are the dimensions of the rectangle when I unroll it. So I hope this will help you remember that part of the formula in case you get stuck or you forget on your quiz or your test why it is what it is. Alright, thanks.